The most important part about permutation is that the order matters. So a lot of times when we have problems like this, it's going to tell you that you're choosing something and you want to know the first place person, second place person, third place person. Or it might be something like there's an election and 10 people are running for this election, and you want to know how many different ways we can figure out the vice president, president, secretary, and treasurer. So when you have a label and when the specific order is important, then we are talking about a permutation. So let's do a quick practice problem. So let's say that 10 students are running for the class school board or the class board. So we want to figure out how many ways can we have a president, vice president, secretary, and treasurer. So it's going to kind of come down to the counting principles. So when we talk about the president, how many different students could possibly be the president in each case? Well, there could be 10 people who could be the president. But then when we get to the vice president, there's only 9 choices. Because we had 10 choices for president, someone got picked to be the president, so now we're down to 9 people. So now we have 9 choices. Then when we get to the secretary, we only have 8 choices because someone was already the president, someone is already the vice president, and now we have options for secretary. And then finally for the treasurer, there are 7 options. So if we do 10 times 9 times 8 times 7, that'll tell us that there's 5,040 different ways that we could have 10 students and we could get a president, vice president, secretary, and a treasurer. What you're going to do is you're going to click this calculator button, and it's going to come up with this calculator over here. So hopefully I can zoom in, which I can. So you're going to click right here is the main calculator, but you're going to go over to function, and then you're going to type in first the number of items in the set, which is 10. Then I'm going to hit that. Oops, I lied. You don't have to type in 10 first. So what it's asking you for is n first. So you're going to type in 10, comma, because I have 10 items in my set, and I'm going to choose 4 things. And when you type that in, your answer will show up right here. So if I have 10 things and I'm choosing 4 things from that set, my answer will be that there are 5,040 permutations that are possible, which is the exact same answer we got when we did it by doing 10 times 9 times 8 times 7. And it's the same exact answer that you get when you use the formula. Okay? So hopefully that makes sense. If I wanted to do a different problem, for example, I wanted to find the permutation. Let's say that there were 12 horses running a race, and I wanted to know the number of ways that these horses could come in first place, second place, or third place, so 3. So 12 permutations with 3, and there are 1,320 possible permutations. So the difference between permutations and combinations is that when we find the combinations, the order is not important. And so the distinction between that, in my opinion, the way that I help remember is permutations are when you're looking for like first place, second place, third place, or president, vice president, treasurer, or whatever. Combination is more about when you're looking for a group of 3 people. So if you have a group of 3, the order that those 3 people are in doesn't matter. It's the same. So for example, if we have Ashley, Kaylee, and Paige, if we have a permutation, Ashley, Kaylee, and Paige is different than Kaylee, Ashley, and page. But if I have a combination, these two things are exactly the same. So today we are going to focus on a combination rather than a permutation. So when we do this, there is an equation that we are going to use. So we have n total things, and we are going to take see how many combinations we can make as in our number of things. So these things still represent the same thing. N is the total number of things, and R is the number that the group size is going to be. So maybe instead of saying the number that, let's call that the group size, what we're looking for. When we're making the combinations, how many things are we putting in the group? Combinations. So you're going to click on this button that says Scientific Calculator. And then instead of being on the main sign, you're going to hit Function. And then you're going to hit N, big CR. So N, combinations. So you have n things. You want to figure out how many groups of R you can make. So let's just make some things up. Let's try. So let's say there are 10 things in a group. I want to see how many groups of 4 I can make. Your answer is 210. Pretty straight. I feel like this part is probably pretty easy for you to do as long as you know that the first number is the total amount of things in the group and the second number is the size of each group that you would like to make.
From that, but how we know when to use each can be a source of confusion. So in general, the sort of rule of thumb that I use is that with permutations, order matters, okay? And so what I mean by that is if you pick one thing, you pick another, a permutation is going to allow a different result if you switch the order of those two. Okay? A combination will not. You choose two things, it doesn't matter what the order is going to be. So permutation, order matters, combinations, order doesn't. Okay? Another way you can think of it is permutation is a way that things are organized sort of in a linear fashion. You go first, second, third, fourth, fifth, so on and so forth, so you sort of place them in a spot. Whereas combinations are sort of just a collection of objects, so you put a bunch of things into a bag, and the order in that bag doesn't really matter. So you're sort of dealing with a linear versus a bag, or a order matters versus doesn't. Either way, permutation is going to be a line, order matters. Combination is going to be a bag, order doesn't. Okay, so either way you think of it, as long as you know that order matters for a permutation, you are okay. So what I want to do is just do a fairly simple example and sort of distinguish the difference between the two. So we have running a race. There's 10 people in it. And there's two things we're concerned with. The first is how many different ways are there to medal. So that takes into account gold, silver, bronze, or other words, first, second, third place. The other one is how many different groupings could there be on the medal stand. So basically there you have a trio of people. No matter what that trio is, it's going to be the same. So if the gold and the bronze person switch places, they're still the same combination on that medal stand. Okay, so we said that order doesn't matter for choosing. Okay, so order doesn't matter means that we are dealing with this sort of general grouping. Okay, so this is going to be a choose. Order doesn't matter. First and third can switch. It's the same combination of everything. And in this case, we're dealing with 10 people, so this is just going to be 10. Choose 3. The difference with that and permutations is with permutation, order matters. So if we switch the first and the third person, we're going to get a completely different permutation. We've switched the gold and the bronze, we're going to get a completely different result. So this one, the different ways are there to medal, is a permutation. The numbers are exactly the same, so this is still 10 and 3, but instead of choosing, we are now using a permutation. Okay, so basically, choosing, order doesn't matter. Permutation, order does.